So in this video, I'll go through the rules of naming an alkane. So alkanes are your simplest organic compounds. These are saturated hydrocarbons, meaning that they only contain carbon and hydrogen atoms, and these molecules contain the maximum number of hydrogen. So with the alkane, the general rules or general steps that you'll see, I'll just number those steps 1 through 4. So step 1, you're going to have your longest continuous chain. That is also known as your parent chain. So the parent chain is just the longest continuous chain of carbon atoms. From there, you're going to identify any substituents. Substituents are simply atoms that are branching from that continuous chain. From there, we'll indicate where everything is located. And then we'll put it all together. So you're going to see these general steps when naming these compounds. And so in order to go through the steps and make sure that you're understanding what I mean by these steps, I'll work an example as I explain the steps. So let's just say that you were given this particular compound. So we only see those carbon-carbon single bonds. So here I am showing a skeletal structure. In that skeletal structure, that means that you only see the bonds between the atoms. You don't actually see the letters for the C, and you do not see the bonds between carbon and hydrogen. So those bonds are present, but they're not shown. In other words, they are implied. So for instance, when we look at this point, and so each point represents a carbon. So when we look at this point, that's a carbon. We can see that that carbon, we see one bond, but we know carbon always wants 4 bonds. So what that tells us is that there are 3 bonds for this particular carbon that we do not see. That lets us know that this carbon has 3 hydrogen atoms attached to it. If I move to this carbon, I can see at this point I have a bond to the left, a bond above, and a bond to the right. Carbon always wants 4 bonds. We can see 3, so there's only 1 that we do not see, so that carbon would have 1 hydrogen. So that's how you can go through and determine the number of hydrogen atoms that are present. But going through the rules of naming this compound, again, we need to identify our longest continuous chain of carbon. And so a tip when trying to identify your longest continuous chain, so trying to identify that parent chain, you can take your finger or a pencil or a pen, whatever you have handy, and you go across those carbon atoms. You're simply starting at one end of the molecule and working your way to the opposite end. May not always be from left to right. It may end up above or below, but you're simply going from one end to the other. Sometimes you have to try it multiple ways. So with this particular example, so if I start at the left carbon, that would be 1, 2, 3 if I decide to go up. In order to include any other carbon, I have to jump over or lift up to get to that carbon. So I am no longer on a continuous chain. So that was only 3. I need to see if I can get more than 3 in a continuous chain. So I can go 1, 2, 3, 4, 5, 6, 7. If I go straight across, I can check to see if there are any other ways. 1, 2, 3, 4, 5, 6, 7. So if you notice, I'm just following those carbon bonds. I could have started up top. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So regardless of which way I try to number this, my longest continuous chain simply has 7 carbon atoms. So instead of me highlighting 7 straight across, because I don't like to get students into the habit of thinking that it's always drawn that way, because it's not. So instead, I'm just going to start up top. 1, 2. I'm just highlighting those carbon atoms. So 1, 2, 3, 4, 5, 6, 7. So in this case, it didn't matter whether I went straight across or whether I highlighted it the way that I showed, or if I started up top and ended to the right. Whichever way I decided to highlight this molecule, I was going to end up with 7 carbon atoms in a continuous chain. From there, I can identify substituents. The easiest way to identify your substituents, look at the part that is highlighted. Look for any bonds that are sticking out of that highlighted area. So I have here, that's sticking out, and I have this one bond even though it contains multiple carbon atoms, but that one bond is sticking out away from my parent chain. So we've identified the parent chain. We've identified substituents. Now we need to indicate where everything is located. So indicating where it's located simply means that we are numbering our parent chain. Based on this particular parent chain, we said that there were 7 carbon atoms, so we're just numbering from 1 to 7. Now with an alkane, I can start counting here. That would be 1, 2, 3, 4, 5, 6, 7. I could have started counting in the other direction. I could have started at the opposite end. This would be 1, 2, 3, 4, 5, 6, 7. So either end could have been number 1. But what you have to remember is once you start determining a location, so once we decide on a direction, we cannot switch it up. We have to remain consistent. So we can only number in one direction. In this case, from left to right or from right to left. From there, we would put it all together. But let's go back to the beginning. What I would recommend as you're going through the steps, once you identify your parent chain, go ahead and write down those pieces of information because then it'll make it easier to put it all together at the end. So the first thing that we did was identify our longest continuous chain, which is our parent chain. I highlighted that yellow. It contains 7 carbon atoms. So we have to name that parent chain. When naming that parent chain, it's going to be based on the number of carbon atoms that were in the parent chain. So the parent chain had 7 carbon atoms. So we have to use the prefix for 7. The prefix for 7 is hept. So hept tells us 7, and because we are naming an alkane, it only has single bonds, it's going to end in ane. So heptane tells us 7 carbon atoms. These carbon atoms are connected by only single bonds. Then we need to identify the substituents. Our substituents were those groups of atoms that were branching from our parent chain. So we had 2 substituents. If we look, we have the substituent to the left. So we had that 1 bond, so that lets us know 1 substituent. That 1 substituent had 1 carbon. So this would be a methyl. Methyl comes from methane. The difference is that methane, so I'm going to deviate for just a minute. Methane is your simplest alkane, 1 carbon, 4 hydrogen. But as I said with this particular carbon, we saw it only had 1 bond. So we know that even though we have this carbon, we see 1 bond. This 1 bond, I'm just put this little squiggly line, that'll be to our parent chain. That means that that particular carbon had 3 hydrogen. So it's not the same as methane. Methane would have 4 hydrogen. Instead it had 1 less hydrogen. So it would be methyl with a YL. That YL just tells you 1 less hydrogen. So this substituent, 1 substituent with 1 carbon is a methyl group. To the right, we have 1 bond branching off of our parent chain, so it still represents 1 substituent, but this 1 substituent contains 2 carbon atoms. So the prefix for 2 is eth. So this substituent is ethyl. Again, derived from ethane, but it has 1 less hydrogen than what the ethane would have. So it becomes ethyl. So we have our parent chain. We have our substituents identified. We can look at the numbering now. So when our parent chain was numbered, if we decided to number from left to right, so starting here, this was carbon 1. This methyl group was located on carbon 2. We had 3, 4, 5 is where that ethyl group was located. But if we had numbered from right to left, we would have started on this end. Our ethyl group would have been located on carbon 3. And then our methyl group would have been located on carbon 6. When trying to determine which way to number, you're looking for the lower sets of numbers. Your substituents want the lower number. So if it's easier for you to figure out both numbers and then add them together, you can do that. But we can see that 2 and 7 are going to give those substituents lower numbers. So we can't say that we can start counting from the left and then change it to the right. We have to count in only one direction. So we would number, in this case, from left to right. So what that means is that this methyl group that we have is located on carbon 2. That ethyl group that we have is going to be located on carbon 5. So we have to indicate where those groups are located. And so now we can put it all together. When you put the name together, you have to list your substituents first. And if you have multiple substituents, you have to place them in alphabetical order. And then you follow it with the name of the parent chain. So that's the general guideline as far as naming any alkanes. You have substituents, and then you have your parent chain. You have to indicate what substituents are present, but you also have to include where they are located. And then if you have different types, you put them in alphabetical order. So in this case, we have a methyl group, we have an ethyl group. So we're comparing that M for methyl to that E for ethyl. So we have to compare those. And so we know that when placing these in alphabetical order, of course the E is going to come before the M. So that means that we would list the ethyl first. We have to make sure we still indicate where that ethyl group is located. So because it was branching from carbon 5, we still keep that number with our ethyl group. So when we put this name together, we end up with 5-ethyl 2-methyl heptane. So that is the name of this compound. That name tells you about the atoms that are present. Now, my recommendation, when you determine the name, just like in math class, you learn to perform the operation, and then at the end, you check your work. You can still check your work in chemistry as well. When you finish with that name, go back and add up those hydrogen atoms, those carbon atoms. F accounts for 2 carbon. Meth accounts for 1 carbon. Hept accounts for 7 carbon. So when you add all these together, your compound should have a total of 10 carbon atoms. If your compound does not have a total of 10 carbon atoms, that lets you know that your name is not correct. So if we go through and count, so I'm not worried about the continuous chain, I'm just counting my carbon. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you can go back and check just to make sure that you are on the right track. So again, the name of this compound is 5-ethyl 2-methyl heptane. When you put it all together with those substituents and where they're located, you have to make sure that you separate numbers and letters by using a dash. So 5-ethyl 2-methyl heptane. And then no spaces. So that is how you would name this particular compound. So we'll work one more example, going through those same rules. So with the next compound, I'm going to just draw another one. So we have this compound. So we'll still go through the steps. First step is to identify your longest continuous chain. So again, you're starting at one end, working your way to the other end. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. No matter how I number this or how I outline my 5 carbon atoms or my longest continuous chain, I'm going to end up with 5 carbon. But the difference is, so I'm going to just redraw the same molecule. The difference is going to be what happens after I highlight those 5 carbon atoms. So if I go straight across, 1, 2, 3, 4, 5, or if I started up top and went down, 1, 2, 3, 4, 5. So both gave me 5 carbon atoms, but the difference is how many substituents. So here I have 1 bond sticking outside of my highlighted area, so that's 1 substituent. Here I have 2 bonds sticking out of that highlighted area. So that's 2 substituents. So even though they both gave me 5 carbon atoms in my longest continuous chain, they differed in the number of substituents. So therefore, if you encounter a situation like this, what you want to do is go with the method that would give you more substituents. So in other words, we want to use this. Think of it as details, or think of it as a map, or if you were giving someone directions. If you were telling them to go to Atlanta, Georgia, would you simply tell them to get on the highway? That doesn't tell them what highway. You gave them one piece of information. But if you told them to get on the highway I-20 west going towards Atlanta, you give them more information. So you're giving them more details about how to get there. The more details that you can provide, the easier it is to identify what's present and where it's located. So if you can determine your longest continuous chain of carbon atoms multiple ways, you want to go with the method that will give you more substituents. In that previous example, it didn't matter. We would end up with 2 substituents. So even though I chose to highlight this way, I had 2 substituents. If I had gone straight across, I would have still had 2 substituents. So that one didn't matter. But in this case, it differs. One way would give me 1 substituent, whereas the other gives me 2. So you want to go with more details. And so with that, if we go through our rules, so I already have the parent chain highlighted. So I can see 1, 2, 3, 4, 5 carbon atoms. Prefix for 5 is pent. Only single bonds, so we have pentane. We have 2 substituents. We have the one at the top that has 2 carbon atoms. So again, we have an ethyl. We have the one at the bottom that has 1 carbon. So again, we have methyl. So ethyl and methyl. And you'll see that these are very common substituents. So you'll see them very often. From there, we want to number our parent chain. So we can start at either end. Left to right would place our ethyl on carbon 3 and our methyl on carbon 4. Right to left would place our methyl on carbon 2 and our ethyl on carbon 3. So again, when you're looking at this, left to right, you have carbons 3 and 4. But right to left, you have carbons 2 and 3. So you want to go with the lower numbers for your substituents. So what that means is that this methyl group is going to be located on carbon 2 of my parent chain. The ethyl group is located on carbon 3. So then we'll put it all together. Again, we have to put it in alphabetical order. So we're comparing that M from that methyl to that E from that ethyl. So of course E comes first. So we would indicate that we have the ethyl first, and we have to make sure that we also include the location. So when we put everything together, we'll have 3-ethyl 2-methyl pentane. All one word. And then the last example that will work, we'll just do this. Still go through the same process. Identify our parent chain, longest continuous chain of carbon atoms. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. If I go straight across, I'll end up with 2 things sticking out. I'll tell you what, I'll just go ahead and draw it 2 other times, just so I can highlight and show the different ways that you can see your parent chain highlighted. So straight across will just be 1, 2, 3, 4. Or if I had started at the top, 1, 2, 3, 4. I could have highlighted that way. Or I could have chosen to start at the other carbon. 1, 2, 3, 4. And you can see that in each case, once I highlight my longest continuous chain, I have this branch sticking out, I have this branch sticking out. I have this branch sticking out, I have this branch sticking out. I have this branch sticking out, I have this branch sticking out. So with this example, in each case, I had 2 substituents. So it doesn't matter which way you highlight. So I'll just work with the middle one since it's the largest structure drawn, and we'll go through and complete the name of this compound. So based on our parent chain, we had 1, 2, 3, 4 carbon atoms in a continuous chain. So the prefix for 4 is but. We only have single bonds, so we have butane. We have 2 substituents. We have the substituent to the left, 1 substituent with 1 carbon atom, so it's methyl. We have the substituent to the right, 1 substituent with 1 carbon atom, it is also methyl. Then we need to number our parent chain. So once you get comfortable with it and confident with naming, you don't have to keep numbering from left to right and right to left. You can look and see that these substituents are closer to the left side of the molecule. So that's a clue that you're going to number starting in that direction. But I'll just still go ahead and number in both directions. And again, I'm just numbering from 1 to 4. So but was the prefix for 4. So we're just numbering 1, 2, 3, and 4. So based on this, if we were to number from left to right, we have a methyl group on carbon 2. We have a second methyl group on carbon 2. If we were to number from right to left, we have a methyl group on carbon 3. We have a second methyl group on carbon 3. So of course we want the lower numbers for our substituents, so we're going to number from left to right. Now even though both substituents are on the same carbon, they're both on carbon 2, we have to indicate that. So we can't just say 2, we have to indicate where they are both located. So that's where the 2, 2 and the 3, 3 came from. So what that means is that this methyl is on carbon 2, this methyl is on carbon 2. So now we can put it all together. But another exception. So as you see, we have 2 of the same substituents, methyl, methyl. Instead of writing 2-methyl, whenever you have multiple of the same substituents, you can use the prefixes di, tri, tetra, so on and so forth. Di means 2, tri means 3, tetra means 4. It just tells you that you have this many of the same thing. So if you have 2 of the same, di, whatever it is. 3 of the same, tri, whatever it is. 4 of the same, tetra, whatever it is. In this case, we have 2 methyl groups. So instead of saying 2-methyl, we're going to call that dimethyl. So dimethyl indicates that we have 2 methyl groups. But we still have to indicate where both methyl groups are located. They are both located on the same carbon in this example. So they're both located on carbon 2. So we have 2, 2 dash dimethyl. So when you're separating numbers, you have to use a comma. When you're separating a number from a letter, you use a dash. And so this molecule is 2,2-dimethyl butane. So I said that was the last example. I do want to work one more with you because I want to make sure that it is understood. Just because it's dimethyl, that doesn't mean that they have to be on the same carbon. It just means that this molecule has 2 of the same thing. So instead of working another naming example, so an example when you're naming a compound, we're going to work an example where I'm going to give you a name and then you'll draw the compound. So let's say you were given the name, I'm going to say 3-ethyl, let's say 2,4, oops, left my dash out, dimethyl nonane. So if you're given the name of a compound, think about how we just went through and named it. We started with the parent chain, then we worked on those substituents. Do the same thing. Think about what this name tells you. Nonane. Non is the prefix for 9 carbon atoms. Ane means that you only have single bonds. So I'm just going to draw the skeletal structure which is what I've been drawing so far. So as soon as I put my pen down, I'm on carbon number 1. So that's carbon 1. And I'm going to zigzag. So up, down, up, down. So that's carbon 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, I chose to go from left to right, starting by going up and then down. You could have gone down and then up. You could have gone from left to right. It doesn't matter. As long as you have 9 carbon atoms in a continuous chain, that's what matters. So even after I drew those 9 carbon atoms, if I decide that I want a number from left to right, I can do that. And so for this video, just so that you don't get into the habit of thinking everything is always left to right, I'll just go ahead and number from right to left. So this will be 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm just writing the numbers down below because I have to go in and fill in my substituents. 3-ethyl, 2,4-dimethyl. So that 3-ethyl, remember ethyl is a substituent that has 2 carbon atoms. Anytime you're drawing substituents, you have to draw a bond to that substituent. That 3 tells me my substituent is on carbon 3 of my parent chain. So locate carbon 3. Since I'm going from left to right, that's my carbon 3. So I have to draw a bond to the substituent. That would be the first carbon. If I left it like that, it's simply methyl. I have to draw my second carbon. So now we have ethyl. Then I have 2,4-dimethyl. Again, dimethyl means that you have 2 methyl groups. That 2 and 4, that tells you where those methyl groups are located. So just because you have dimethyl doesn't mean both methyl groups are on the same carbon. You have to use those numbers to determine exactly where they are located. So 2,4-dimethyl tells you that you have 2 methyls. One is on carbon 2, so go to carbon 2, draw a bond. I only need 1 carbon, so as soon as I draw my bond, that's my methyl. Carbon 4 is where my second methyl is at. So I'm going to go to carbon 4, draw a bond. As soon as I draw that bond, that's my methyl. So I have my structure of 3-ethyl, 2,4-dimethyl, nonane. So if you're given the name, just start with the parent chain, then fill in your substituents. If you're given this structure, you still want to start with the parent chain and then identify your substituents. So I hope that this helps with naming and drawing alkanes. Thank you.